This is the project proposal presentation for Robot Dynamics class RBE 501 by Team 3. The team members for this project are Terence Carmichael, Amit Trivedi, Kiran Mohan, Aman Rana, Akanksha Devkar. In this presentation, Aman will give an introduction to DaVinci Research Kit and the project overview. Amit will define the purpose and objectives of the project. Akanksha will define the audience that could benefit from the outcome of the project. Amit will present the project deliverables then. Kiran will describe the scope and execution of the project as well as the project timeline. And finally, Terence shall go over the challenges anticipated during the project.
Hello everyone. In this project, we will be using the DaVinci Research Kit robot. It was created by Intuitive Surgical for research purposes by universities. It consists of a surgeon's console and a patient side console. The surgeon's console consists of two master tool manipulators and a foot pedal tray for surgeon to control the two patient side manipulators. The DaVinci surgical robot was made to aid minimal invasive surgery, and the benefits include smaller incision, less pain and scarring, less loss of blood, reduced chances of infection as the incision made are very small, faster recovery time. In this project, we aim to model the kinetic and dynamic model of the DaVinci manipulators using the various principles of robot dynamics like Jacobian matrix, DH parameters, forward and inverse kinematic, etc. to perform adaptive admittance control of the manipulators. This means to exert a constant amount of force on the tissue irrespective of the movement of the tissue or the end effector. We also plan to model the force feedback to the surgeon's console manipulators, thereby giving the additional sensory feedback to the surgeon. This is aimed at making the use of DaVinci robot more intuitive.
Thanks, Aman. Many tasks performed by a robot manipulator require the robot to interact with its environment, and it necessitates that a robot realize its predisposed position. Additionally, the robot manipulator either needs to overcome the resistance from the environment or comply with the environment. Hence, admittance control is used for compliant motion control. For this project, we have two purposes. The primary purpose is to achieve admittance control of the patient side manipulator, or PSM, in the DaVinci Research Kit by regulating contact force at the PSM tip. Here our objective is to maintain the deflection of a soft body as the PSM tip pushes against the body. For this objective, we shall monitor the change in the PSM tip position and measure the output current of the joint motors and the Jacobian to compute the contact force. Our secondary purpose is to develop a model of actuators and sensors that would produce a simulation of the PSM tip contact force at the main tool manipulator, or MTM, which is on the surgeon side. For this, the objective is to provide the operator of the MTM, that is the surgeon, to experience a similar force or the same force at the PSM tip. For the secondary objective, we shall monitor the contact force at the PSM tip and measure the artificially produced force by the modeled actuator sensor system at the MTM. As our overachieving goal, we wish to apply the developed simulation model to the physical DaVinci Research Kit in AIM Lab located in WPI.
Thinking of the audiences, we can take students and researchers working in the field of robotics, mechanical or instrumentation field as the primary audiences of DaVinci Research Kit. The secondary audiences are faculty in the field of robotics engineering. As robotics applications are expanding, not every application needs to have a strong grasping force. As this project aims at admittance control of manipulators, it has vast applications that can be included in the tertiary audiences. It can obviously be used as surgical robots in the medical industry. It can be used in the electronic industries for handling thin wafers. It can be used for handling fragile food items. In automation industry, it can be used for handling ceramic catalytic converters. It can also be used for handling wax patterns in investment casting. And as an interesting application, it can be used in space exploration for handling fragile evidences.
Thank you, Akanksha. So for the project, here we have outlined our primary, secondary, and tertiary deliverables. We plan to obtain a thorough understanding of optimal interaction control which will help us understand how to adjust the gains and damping parameters so as to find the optimal interaction control. We definitely aim to achieve the primary and secondary deliverable. At the end of the project, we plan to demonstrate the model with simulation, and our overachieving goal is to be able to do physical demonstration with the DaVinci kit by pulling a string held by the PSM to show the use of admittance control. Additionally, we also hope to submit our findings for publication in an academic journal.
Moving on to the scope of the project, we would like to regulate the contact force experienced by the end effector in order to simulate admittance control. Secondly, our interest lies in using the force at the PSM tip to simulate haptic feedback onto the MTM. Thirdly, our overachieving goal would be to implement the simulation on Intuitive Surgical's DaVinci Research Kit available in the AIM lab. The project will be done within the scope of the topics covered in the Robot Dynamics course. Regarding the feasibility, our primary objective is simulating admittance control, and since this needs only computing resources, it is feasible to complete this part within the given time frame. Our secondary objective is simulation of haptic feedback, which also requires only computing resources. However, our overachieving objective of implementing our simulation on the actual dVRK system would be the least feasible goal due to time constraints and resource requirements such as the actual physical dVRK system. A solid understanding of robot dynamics and robot control, as well as skills like robot modeling, simulation, and sensor integration would be required for this project.
Hello, my name is Terrence Carmichael. Today I'll be presenting the challenges slide for the DaVinci Robotics project. Some of the challenges we anticipate include analytically solving and implementing adaptive admittance control of the patient-side manipulator, achieving a high level of effectiveness. We anticipate include analytically solving and implementing adaptive admittance control of the patient-side manipulator, achieving a high level of effectiveness with our design and managing the team deliverables, priorities, and logistics. To remedy these challenges, we'll be executing a comprehensive verification with our design and managing the team deliverables, priorities, and logistics. To remedy these challenges, we'll be executing a comprehensive verification and validation plan. This will help ensure the software developed meets the specifications and user needs. We'll utilize revision control software to verification and validation plan. This will help ensure the software developed meets the specifications and user needs. We'll utilize revision control software to protect each iteration of development while multiple users engineer. To maximize our design's effectiveness, we'll perform a thorough research and analysis of each iteration of development while multiple users engineer. To maximize our design's effectiveness, we'll perform a thorough research and analysis of past and present surgical technology in parallel with our analytical practice throughout the semester. Lastly, we'll utilize consistent communication strategic past and present surgical technology in parallel with our analytical practice throughout the semester. Lastly, we'll utilize consistent communication strategic planning to meet milestones, prioritize deliverables, and deal with the logistics of everyone living in different areas. Thank you for your time. Bye. Strategic planning to meet milestones, prioritize deliverables, and deal with the logistics of everyone living in different areas. Thank you for your time. Bye.
The timelines for the activities involved in the project are shown in this slide. We plan to finish the complete simulation by the first week of April so that we have the time for any potential modifications and improvements and implementation on the physical DaVinci Research Kit system.
Thanks, Terrence. So to summarize, We briefly described the DaVinci Research Kit, the project overview. We stated that our primary purpose is to achieve admittance control in order to regulate contact force at the tip of the patient site manipulator. And our secondary purpose is to develop a model for force feedback at the surgeon site manipulator, or the MTM. We also stated that our primary audience would be students and researchers, but additionally the people from academia and industry both can benefit from admittance control. We reviewed our primary and secondary deliverable. We described the scope and boundaries of a project and what was feasible. We looked at the project timeline. And finally, we reviewed challenges anticipated in the project. We also realized that to compute the static force itself will be challenging and computationally involved. We look forward to achieving our goals for this project. We hope that this presentation provided a good overview of the project. Please provide your feedback on our project proposal presentation. Thank you for your time.